All right, for 21 through 25, we are writing the balanced formula equation, and then we're going to do a complete ionic, net ionic, and identify any spectator ions. So the first thing we have to do with this one, we already have the products, so we have to balance. 2 sodium, put a 2 here, that balances the sodium. It also balances the chlorine. That's now balanced. You will notice all the different states, the aqueous and the solids, were already listed for this one, so that's great. And so we're going to go and do the complete ionic. So anything that is aqueous is completely going to ionize, going to separate into separate things. So in this case, we have 2 sodiums that are positive, and they're aqueous. We have 1 carbonate with a 2 minus. It is aqueous. We have 1 iron that in this case is going to be 2 plus. It is aqueous. And then we have 2 chlorides that are 1 minus. They're aqueous. Okay? The iron 2 carbonate is a solid, so you leave that thing together. All right? And then notice the sodium chloride is aqueous, so we have 2 sodiums that are aqueous, 2 chlorides that are aqueous. All right, so that is our complete ionic. For the net, we're only going to include things that change. Did sodium change? No. So it's a spectator. Did carbonate change? Yes, it did. So we're going to include carbonate. So we have carbonate ions. Did the iron change? Yes, it did. So we went from iron with a 2 plus. Okay. And did chloride change? The answer is no. So what do these things change into? Iron 2 carbonate, which is solid. So that is our net ionic. If we want to do spectator ions, the ones that didn't do anything, that would be sodium and chlorine. There you go. Okay, next for 22, same kind of deal. And so first thing we have to do is balance this guy. Let's see. We have 3 calciums, and so if I put a 3 here, that balances the calciums. The nitrates turn into 6. I'm going to put a 6 here. Let's see, phosphate, I have 2 and 1, put a 2 here. That also balances the hydrogens at 6. So 3, 2, 6, 1. Okay, complete ionic. We have 3 calciums, each at a 2 plus. We have a total of 6 nitrates, because the 3 times the 2, there's 6 nitrates at 1 minus. 6 hydrogens that are each a 1 plus. 2 phosphates that are 3 minus. So there's all of our reactants. For the products, here's the aqueous ones. We have 6 hydrogens that are aqueous. We have 6 nitrates that are aqueous. And then calcium phosphate is your solid, so it stays together. There's your S. Okay? All right. Let's take a look here. Did calcium change? Yes, absolutely did. So it's going to be part of the net ionic. So we're going to have 3 calciums with a 2 plus. Did nitrate change? No, it didn't. Did hydrogen? No. Did phosphate? Yes. So 2 phosphates. They're aqueous. And then calcium phosphate, that's your net ionic. What were the spectator ions? Hydrogen and nitrate anions. Okay. For 23, this one we have to predict some products. Okay, so the first thing you realize, this is probably going to be a double replacement. We have 2 compounds, it's going to turn into 2 new compounds. And it's kind of like foiling in algebra. The outer ones go together, the inner ones go together. So the cation of the first will go with the anion of the second. The cation of the second will go with the anion of the first. So barium is going to go with sulfate. Barium is 2 plus, sulfate's 2 minus, so it's BaSO4. What's left over is potassium and chloride. Potassium is 1 plus, chloride's 1 minus, so it's KCl. To balance this thing, all you need is a 2 here. Okay? All right, so we notice both reactants are aqueous. That's fine. Now we have to look at the products. So I look at my solubility table. I look and see where barium and sulfate intersect. and you'll notice that it says it is insoluble, so I need to mention this is a solid product. When I look at potassium and chloride says that it is soluble, and so that's aqueous. Now it's just the same as the other problems. Okay, so we have barium with a 2+, that's aqueous. We have 2 chlorides, that's 1-, that is aqueous. We have 2 potassiums that are 1+, that are aqueous. We have 1 sulfate, that is 2-, it is aqueous. Arrow over, the barium sulfate is solid, so it's one thing. And then these turn into separate ions. We have 2 potassium cations that are aqueous, 2 chloride anions that are aqueous. Okay, well, barium, did it change? Yep. So we're going to have barium. Did chlorine change? No. Did potassium change? No. Did sulfate? Yes. And so we have sulfate anions. And so they're going to turn into barium sulfate. For my net ionic, there's the solid. Spectator ions, potassium, and chloride. Okay, next, we have magnesium chlorate, potassium acetate. So once again, magnesium is going to go with acetate. Magnesium is 2+. Acetate, C2H3O2, is 1-. 2 comes behind here. What's left over? Potassium, 1+, chlorate's 1-, so it's KClO3. In order to balance this thing, you would need a 2 here and a 2 here. That's going to balance the potassium, the chlorates, and the acetates. All right, so we notice both of the reactants are aqueous. If I look at magnesium acetate, it says it's soluble, so this is aqueous. For the potassium chlorate, it's also soluble, so this is aqueous. Okay, because everything is aqueous, this is not a chemical reaction. Every one of these things is a spectator ion because no new products are formed. Yeah, they all start as ions in the solution in the beginning. They're all ions in the solution at the end. They are not changing into new substances, not a chemical reaction. 25. Sodium sulfide and cadmium nitrate. Well, let's see, is cadmium? Let me look. I don't remember if it has more than one charge or not. Nope, looks like it's fixed too, so it's just cadmium nitrate. All right, so sodium is going to go with nitrate. So it's going to be NaNO3, 1+ and 1-. Cadmium is 2+, sulfur is 2-, so it's CDS. Okay, and looking at the solubility table, this one is soluble, so AQ it is. Cadmium sulfide, now that one is insoluble, so that is our solid precipitate. To balance, all you need to do is put a 2 here and we're good. Okay? Complete ionic, 2 sodiums with a 1+ that are aqueous. There is 1 sulfide, that's 2- and aqueous. There is 1 cadmium, which is 2+, that's aqueous. There are 2 nitrates that are 1- and they are aqueous. Okay? So the sodium nitrate has 2 aqueous sodium cations, 2 nitrate aqueous anions. Cadmium sulfide is your solid. Okay, which things changed? The sulfide anions. Cadmium cations changed. Okay. Spectator ions are going to be sodium and nitrate. Those are your anions. Okay, so that was it for complete ionic, net ionic, spectator ions. So what we have now is we're looking at some thermochemistry problems. And so looking at this first question, it says, do the products have more or less energy than the reactants? Well, in looking at this, reactants definitely lower in energy, products higher energy. So do the products have more or less? In this instance, they obviously have more. Is this reaction endothermic or exothermic? Well, if we look at this, let's stop and think. Is the heat going in or is heat going out? Okay, so in this instance, reactants are low in energy, the products are high. That means energy had to go into the system. And so which one goes in? Endothermic. And then next it says, is the reaction enthalpy, which is that delta H, so that change in heat, is it positive or negative? Well, if you look at it, the energy is going up, so delta H in this instance would be a positive value. Okay, next one. Do the products have more or less energy than the reactants? Well, here are the reactants up here, here are the products down there. And so they obviously have less. Is this reaction endothermic or exothermic? Well, it has less heat at the end, so where did that heat go? It went out somewhere into the surroundings, which makes that one exothermic. Is the reaction enthalpy, the change in heat, is that positive or negative? Delta H in this instance would be negative. Okay, the last part said circle the parts of the graphs above that show the energy that it takes to break bonds. Okay, so that's going to be this portion on this graph, this portion on this graph. Okay, it says put a box around the part where energy is released when forming bonds. Well, it's probably going to be this part here and this part here. So there is the releasing of energy. And then finally, it says which of the previous reactions would feel cold to the touch? Well, ones that feel cold are going to be the endothermic, the ones that are absorbing heat from the surroundings. If you are touching this beaker, this thing is taking place in this reaction, it's absorbing energy. It's absorbing energy from the surroundings. Guess what? You are the surroundings. This one is the endothermic reaction.